Hi, everybody. Welcome to How Heat Stress Affects Sheep Reproduction. My name's Heather. I'm your member relations person with Ontario Sheep Farmers, and I have with me tonight Dr. Bobbie Baida and Dr. Jamee Daly, and they are joining us all the way from Adelaide, Australia, to talk about their research. Dr. Van Witter was unfortunately not able to join us last minute to something that he had come up, but I'm sure that the two researchers we have with us will do a fantastic job of their presentation. I'd like to thank you for coming. And our next speaker series presentation will be on February 18th, and it's titled Avoidable Losses, and it's featuring Dr. Lisa Sharko, who's OMAFA's lead veterinarian and animal health and welfare. She'll be discussing preventing economic losses due to caseous lymphadenitis and Cysticercus ovis. And we will have questions at the end of this presentation. And if you'd like to type them in the chat through the presentation, we can field them all at the end. That's great. Take it away, Dr. Daly and Dr. Baida.
Perfect. All right. Well, Heather, thanks so much for having us. It's really great to be able to share our research to an international audience. And just speaking with you now about the extreme heat that you get over there. I guess we weren't, or I certainly wasn't aware of the extreme. You sort of can meet the extremes that we get here in Australia, and similar issues. You know that you have to hit your sheep at an Easter market, so you're breeding. You're getting some extreme heat at critical time points, which is sort of all about what our research is looking at. So how heat stress affects sheep reproduction. How different sheep regulate their temperature, and if there's variation in this, and then how we can alleviate this, and mostly, practical management strategies that can be implemented in the field. So I'll just start with, I guess, giving a shout out to the team. So obviously Jamie and I are presenting today, but there's a huge group of people behind all of this work in various years and in various aspects of this research. I won't go through and name everyone, and I always say and others because I never want to miss anyone, but there's just a huge team of people behind all this work, as well as the organisations that they're from and various collaborators and funding bodies around Australia. So all of the major sheep funding bodies have contributed to this research in some way. And couldn't do it without everyone. So Associate Professor Will Van Wetter, as Heather said, wasn't able to speak this evening, but he's a project lead on many of these projects. And then we've got Dr. Elise, Alice, and obviously Jamie out at SARDI, based out at Turretfield Research Centre. And then some really important senior researchers that bring their own expertise to this work around reproduction, some of the behaviour aspects, and certainly some of the earlier work that was done in this space that has sort of led us to this point. So, yes, as I said, so the research, the main thing we're interested in is, the impact that heat has on sheep reproduction and fertility. So just to a bit of context, you can see the map there of Australia, and you can see that little brown pin down the bottom. So, we're in southern Australia. Generally, this is sort of, we hold a bit of a Mediterranean climate. So up in the northern states and areas, it gets a lot more humid. So, but down there, it's sort of a drier heat, and we certainly get those temperature extremes. I think it's going to be 45 degrees this Saturday, only getting to about 25 overnight. So we certainly get the brunt of the heat down there as well, especially in northern parts of southern Australia. As I said, we sort of looked at if there's individual variation in thermoregulation. So we're really interested in how sheep, if they vary in their ability to regulate their temperature, and some are essentially more resilient in that aspect to this extreme heat, and certainly to variations in climate when the temperature can go up and down. That's where a lot of our research stems from. A lot of the early work around the impact of heat has been done in, controlled chambers and climate-controlled rooms to sort of simulate that extreme heat. And our research is really trying to investigate it in the field. But I'll go into more about that soon. And as I said, then we're going to touch on practical strategies and interventions that we're trying to implement and investigate that are able to reduce the impact of this heat in the field, which is what Jamie will be talking about. So what we do know, like I said, we generally have a Mediterranean climate, so humidity is less of a factor. So focusing on ambient temperature in our sort of climate, generally we think of extreme heat as anything over around 30 to 32 degrees, and that seems to be when heat has the most impact on animals. So some early work has found each day over 32 to decrease lambs born by 3.5%. If animals are getting pregnant, we find that heat stress affects the lambs in utero. So heat stress during pregnancy reduces lamb birth weight by between 16 and 36%, which therefore generally affects their survival and their vigor. Smaller lambs are unable to thermoregulate as well, and this can often affect their survival. So indirectly, we can see a reduction between 20 to 30% in weaning rate as well. With rams, like a lot of the researchers, we focus on the ewes, but rams play a huge role in productivity, and the effect on them is a little bit harder to manage because you're often seeing decreases in ram fertility 9 to 50 days following a heat event, so having that delayed effect, and that's due to the 5-week sperm cycle of spermatogenesis in the ram. So depending on what period the heat is exposed to these rams, and it can affect them at various stages in that spermatic cycle, and then that's affecting their reproduction later on. So even if you have relatively mild conditions during joining, the rams may have been influenced by some extreme heat earlier on. So yeah, that's something really interesting and something we consider when monitoring heat. So overall, this is expected to cost the industry up to close to 170 million per year, and that's as is. If we're seeing a 1 degree or 3 degree increase in temperature per year, this is getting up to over 270 million annually. So just extreme economic losses for producers, and often they're considered sort of like these unexplained losses, but often you'll find that it's these suboptimal conditions around joining that we have to endure, and the sheep have to endure. So sort of, run through this a little bit, but basically heat can impact sheep at a few different time points, but ultimately it's reducing the number of lambs weaned. So in the ram, it's affecting the sperm quality as well as the concentration and number of sperm, as well as their libido and their behaviour and their willingness to join. If you're getting really extreme heat during joining, maybe it doesn't directly affect their sperm at that point, but they may be really reluctant to seek out the ewes in that really extreme heat, especially in like rangeland environments. In the ewe, previous work has found it to affect the duration of estrus and the incidence of estrus, which affects then things like ovulation rate, embryo quality, and also embryo loss in the ewe. And then again, if they are falling pregnant, the pregnancy conditions and maternal behaviour can affect the number of lambs born alive and that are surviving through to weaning. And as I said, in the lambs, we're seeing reduced birth weights from maternal heat stress, which affects their thermoregulation and vitality, and ultimately their survival through to weaning. So around mating, so what you're looking at here is day 0 is the day of mating. Below the line is the ewe, and above the line, that timeline is the ram. And the brown is hypothermic temperatures, so above average temperatures, above 32, and the cream is just like normal temperatures. So like I said, even if you're getting normal temperatures around the time of joining, so 2 weeks prior to joining, you're still seeing reductions in fertility in the rams if they've had heat between 14 to 42 days prior to joining. And again, those characteristics and aspects of ram fertility are listed there. So sperm number, but also abnormal sperm, which affects then embryo survival and pregnancy rates in the ewe. And then, in the ewe, it's I guess a bit tighter. So, the week prior to and after joining is the most critical point for the ewe in terms of how their reproduction is directly affected by heat. And then, as I said, through gestation, basically this sort of says that you're getting heat at any point in gestation, it can have effects on the lamb. So that's what that's saying. So even if you're just getting it in late gestation, it can still have effects on fetal growth in utero. And then it's also affecting milk production from the ewe postpartum as well. And these effects aren't necessarily additive. So, just because they're getting heat through early, mid, and late doesn't mean the effects will be larger necessarily. It just really depends on the duration and frequency of that heat and as to how the ewes are able to cope with that heat. So I guess what is heat stress? I guess ultimately it's when the ambient temperature or the environmental temperature exceeds the animal's upper critical temperature. So they will have a temperature where they're, I guess, able to, maintain their homeothermic state, and they're in a comfortable, temperature, a core temperature. And it's when temperature exceeds this that they start to exhibit physiological responses to try to emit that excess heat. So they increase their respiration rate. They reduce their behavior. They reduce their feed intake. They increase their water intake. They're more selective on their movement and resource use. But ultimately, if they're still not able to maintain homeothermy, their core temperature will exceed normal range. So in sheep, it's about 38.3 to 39.9 is a normal range of core temperature in animals. So basically, stemming from that, our research is based around looking at core temperature in sheep to infer heat stress. So looking at their core temperature is a major way to identify if they are under thermal pressure and are exhibiting heat stress, because those mechanisms haven't been able to emit that excess heat, or they've had prolonged heat exposure. So we want to see if there's a difference in an individual's ability to cope under heat based on their core temperature, if this affects their fertility. And in the ewe, the main things we're looking at is ovulation rate, follicle development, fetal growth, reproductive output, and also lamb viability, and then mostly semen quality in the rams, but also success of joining at the ram level as well. So I guess the start of my passion in this area was through my honours, but then also my PhD, which I have recently completed and graduated from. So my PhD was titled Thermoregulation in Response to Heat Stress in Sheep and the Impacts on Fertility. So I sort of spoke a bit about the approach that we took. I guess it's easy enough to say measure a sheep's core temperature. It's really hard to implement that in the field and get enough strong data and accurate data to be able to categorize these animals, but also monitor their core temperature at a regular interval. So taking a rectal temperature, for example, you've got to restrain the animals, catch and restrain them. And being a fight or flight animal, this induces its own stress response. So it's difficult to say that those readings of core temperature are an accurate representation of their thermal state as opposed to a stress response due to the handling. So the first step of my PhD was to develop a method that we could use to monitor their temperature continuously in the paddock, which is, a step forward from all the controlled trials using sort of rooms and chambers and manual methods of temperature. So we worked with some engineers within the university to develop a method. We found some highly accurate temperature loggers. We needed to ensure they had enough sensitivity to be able to detect, really small differences between individuals, because as I mentioned, that temperature range is quite a tight range, so 38.3 to 39.9. It's not a huge amount to work with, so you need to have a really high level of accuracy in the way you're measuring. And then we developed a way to deploy those loggers. So in the ewes, we went with a vaginal mold, as a measure of core temperature. So vaginal temperature and rectal temperature, which is a traditional core temperature measurement, are very highly correlated. And so we thought we would use this as a way to monitor their core temperature. So I'm sure a lot of you have used CEDA devices before, so controlled internal drug release devices. They're a way to synchronize use into estrus before, artificial insemination or joining strategies. So we basically used that as a replica and created a mold that could house a temperature logger. And then we inserted these intravaginally in the field. So in terms of numbers, we got as many loggers as we could and monitored enough, like as many as we could that was realistic to artificially inseminate and monitor throughout gestation and lambing. So we started with about 200 ewes and deployed these loggers intermittently through a summer joining in 2021 and 2022. So we monitored them under grazing conditions, monitored their body temperature. We took these loggers in and out. So, we plan it around heat, but generally they were only in for 7 to 14 days at a time. We would take them out, wash them, download the data, disinfect, and then reinsert them following another heat, like when another heat event was predicted, just to get enough data to really profile these animals, and look at repeatability and against ambient temperature and how it was interacting. We also wanted to look at their behaviour. So these animals are in the paddock under normal grazing conditions. We wanted to look at how they were using shade and water resources and what their activity and movement patterns were. Because, of course, this is all going to affect their physiological response to the heat as well. So we wanted to look at the whole picture. I guess the ultimate goal is to then find sheep that are able to maintain a lower core body temperature under heat and select for these and see if they have different reproductive output. So comparing a low and a high responding cohort in terms of their fertility outcomes. So this was the basis of our classification in grouping. So like I said, the loggers were deployed. At the end of the research period, we looked at the data and categorized them based on low thermoneutral or high vaginal temperature. And this was limited to hot conditions. So the main thing we found out looking at the data is just the way it behaves under environmental temperatures and how it increased with ambient temperature. And what we were really seeing is a tease apart in individuals and more of a spread at those higher temperatures. So when they're put under more pressure, we're getting those different phenotypes express themselves. So it was limited to hot temperatures, and then we essentially selected the lower and higher quartiles, and then we had a thermoneutral group in the middle, and then the remaining sheep were impartial. And then we deployed a subset of each of the cohorts with GPS collars to monitor behaviour. So this is just a regression showing the low and high temperature cohorts in response to ambient conditions. And like I said, you're seeing a pretty linear relationship with ambient temperature, but you're really seeing a segregation of those groups, temperatures sort of above 30. So that's where we limit our temperature classification is to those higher temperatures, so we can look at those groups when they're really put under pressure and how they're coping with the heat. This is just a bit of a map of their GPS locations. So we just looked at point counts. We created shade polygons for the shade areas, so we knew when they were in and out of shade, and we could look at their temperature in and out of shade, and just looking at their general activity. So there was the temperature loggers were recording every 10 minutes, as was the GPS column.
Thank you.
And also the environmental temperatures were also recording every 10 minutes, so we could get a really thorough understanding of that interaction. So looking at the effects of shade use and movement, obviously a big factor is solar radiation. So we wanted to eliminate any bias with how the solar radiation was, and it's really hard to do that just based on time alone, because obviously that changed. The amount of sun exposure changed throughout the monitoring period. So we broke it up into 5 discrete time intervals. Each were 3 hours long. So around solar zenith. So around that midday interval. So we looked at total shade use in minutes, distance travelled, and then you can see their vaginal temperature at each of the time periods. So at all the time periods, the high temperature cohort was significantly higher than the low responding animals. This is expected because we selected them based on their temperatures under heat. So we expect differences in that core temperature to remain and be repeatable throughout the research period. Overall, low responding animals travelled less distance than high responding animals, which was really interesting. And then I guess, is it the chicken or the egg? So the high responding animals were travelling further. Is that why they had a higher temperature? Or are they travelling, because they need to use resources like shade and water more often? And, we also looked at body condition and weight, which I will get to. But generally, their shade use was pretty similar across all time periods and overall. But you can see that it was highest at the midday interval. So they were in the shade at that midday interval for a large portion of that time interval. So we're looking at, when looking at the vaginal temperature in and out of shade, so the effect that shade had on their physiology, we're seeing a huge reduction in core temperature when they were in a shade polygon, so when they were in the presence of shade. But interestingly, the low responding ewes were significantly affected when they were in the shade. But you can see no difference in the high responding animals in the shade, which tells me they aren't recovering in the presence of shade as well as their low responding cohorts or counterparts. So that was a really interesting takeaway. Could be due to, their ability to recover in the presence of shade and offload that heat as effectively as a low responding individual. So I've sort of skipped straight to lamb birth weights, but I should mention all the reproductive differences we found. We actually didn't find any differences in, ovulation rate or scanning percentages in the ewes. But I should mention that, so we had 50 in each of the temperature cohorts, but after they were artificially inseminated and then pregnancy scanned, we removed all the empty individuals following AI, and all the percentages were about 70%. So when you're getting down to about 30 animals per group, it's really hard to find those differences in, proportion measurements like reproductive rate and lambing rate in that number of in that cohort size. But everything was going in the right direction. The low responding animals had a high ovulation rate. I can't say high, it wasn't significant, obviously, but numerically everything was moving in the right direction. And I really think with more animal numbers and more extreme heat, we would have really seen some differences in those fertility metrics. But what was interesting was that we did see a reduction in twin lamb birth weight. So the low responding ewes had the heaviest twin-born lambs. This was like a lot heavier than the thermoneutral group. It wasn't significant, but it was, they were 230 grams heavier on average than the thermoneutral and 180 grams heavier on average than the high temperature group, which, even though not significant, I would say, close to 200 grams in lamb birth weight is pretty biologically relevant in the scheme of things, and when you consider the range of a typical twin lamb birth weight. And you can also see the numerical pattern there with the single-born lambs as well, and the low-responding animals having the heaviest single-born lambs. So we also looked at a similar thing and took a similar approach in the rams. Obviously, we couldn't use our vaginal deployment method in the rams, so we used the same temperature sensors, but we did surgical implantation in the rams. So We used axilla temperature, or it's like in the armpit, as like a proxy for core temperature. Although it is quite peripheral, so we did consider that when looking at the data. And we also used one in the scrotum. So looked at scrotal and axilla temperature as a measure of core, and looked at, similar things across the board. So how their temperature interacted with environmental temperature, if we could tease apart these distinct phenotypes or temperature cohorts, and then whether that affected the ram fertility. And that was in the way of semen quality. So we trained these animals for semen collection, monitored that through a summer period as well. What's really interesting is that we selected these rams from the U cohort in the previous study. So we could look at also transgenerational effects of heat tolerance from U to ram lamb. So this is just some more regressions about how both scrotal and axillary temperature was interacting with ambient temperature through the trial period. What's also important to mention is, although we had those two measures of temperature, the difference between the two is also really important. So to maintain a difference between 4 to 6 degrees between core and scrotal is ideal for the process of spermatogenesis. And when that difference starts to reduce is when you can see some effects on semen quality. So we wanted to look at the difference as well as each of them respectively. So again, you're seeing a bigger segregation at higher temperatures, especially in the axilla temperature. It's a lot more consistent. Obviously, scrotal temperature, we expected it to have more variation because they have mechanisms in place where they can regulate their temperature and move the testicles to closer to the body and to regulate that temperature. And so we're seeing a lot more variation in those scrotal temperatures. So when looking at, some standard semen quality characteristics between the temperature cohorts, so again, we grouped them based on their scrotal and axilla temperatures. We did that separately. So we looked at high and low scrotal temperatures and high and low axilla temperatures, because this is all relatively novel work, and in terms of temperature classification in these animals. And so we just wanted to look at, which had a larger effect or how they were interacting. So the main things were the low scrotal group had a higher volume and also a higher total sperm count than the higher responding animals. So those with the lower core temperature generally had higher sperm count and more of it. And then those with a lower core temperature had a higher concentration of sperm. So I should mention also there was about 10 per group. So again, we had to be realistic with the animal numbers and what we were able to monitor. It's quite an intensive trial, as you can imagine. But generally they were all successfully mounting at around 9 months of age. So they were trained, and so they were relatively juvenile too. So keeping that in mind when looking at some of the motility measures and things like that, they were still relatively young individuals at that time. So I guess the key findings, I was meant to put a graph on, but with the transgenerational impact, so rams born to the low responding ewes actually did have significantly lower axillary temperatures than those born from the high temperature ewes, which was a really interesting takeaway. Obviously, there's a lot more research that would need to go into that in terms of, genotyping and just, I guess repeatability of that. But I thought that was a really interesting takeaway, and I guess puts promise into being able to detect transgenerational effects and being able to select for a trait like core temperature. But I guess to summarize, variation in heat stress response was repeatable and obviously environmentally influenced. So we did repeatability measures and found that we were able to consistently pick up these different cohorts. And we found that in higher temperatures, this was a lot more consistent. So it was significantly more repeatable at temperatures, above 32 degrees. So we know sort of the way we can measure those phenotypes and get the most repeatability, I guess, and validity of those groups. And it was the same in the ewes and the rams. So the high responding ewes, they travelled further, but they were actually in lower condition than the ewes at weaning. So that was a really interesting takeaway as well. So we found the presence of shade significantly reduced the core temperature in the low responding ewes. So the low responding ewes obviously had a lot lower core temperature than the high responding animals under shade, but shade seemed to have a larger effect on those low responding animals. As I said, they were in better condition. So I thought this was really interesting, given that the high responding animals travelled greater distances, so they had higher activity. You would think maybe they were therefore, not grazing as much, or they would be lower in condition due to that extra activity. But in fact, the low responding animals were actually in better condition, which was really interesting. Like I said, the twin-born lambs were 180 grams heavier than the high responding, those born from the high responding ewes, which I think is a biologically relevant difference in weight and something to be further investigated. As I said, we didn't see any significant differences in reproductive rates. Like I said, this partly could be due to animal numbers, but also throughout my PhD, of course, we had some relatively mild summers. So the heat could have been like a lot worse. And we certainly do get much, much higher heat. We did have, high temperatures, but I think having that ability to offload heat overnight and intermittent recovery, access to shade, it all helps these animals recover and cope with the heat. And I think that in hotter conditions, all of these sort of numerical difference might have been exacerbated into something more significant. So certainly wasn't too disheartened not seeing those significant results with reproductive rates. I think, the effects would be there under different circumstances. So high responding animals reached hypothermia at lower ambient temperatures. So we're finding they're affected with heat with a lesser ambient temperature. So maybe the high responding animals started exceeding their normal range at temperatures of 28 as opposed to 32 in the low responding animals. In rams, like I said, repeatable and influenced by the environment, similar to the ewes. We found lower scrotal and core temperature linked to increases in some semen characteristics, so semen volume, concentration, and total sperm count. Their thermal traits were repeatable. And yes, we did sort of see some early results for transgenerational influence. So those lambs born to low responding animals also had a lower core temperature on average under thermal pressure. So yes. This is my last slide. So just sort of a vision into our future work. So sort of expanding on that PhD work, we were really wanting to also not only look at the sheep and, thermal resistance and resilience to climate and drought, but also trying to look at the system around them. So we're looking at building supportive and resilient feed-based systems, creating shelter belts and microclimate to be able to help these animals, maintain productivity through a changing climate. So we have some really cool long-term trials in the pipeline looking in this space, taking all this work commercial as well, which we have done. So a lot of the logger deployment also happened on commercial sites, which Jamie will go through. She'll touch on a bit. And we want to develop, I guess, tools and strategies for producers to be able to, maintain productivity through a changing climate and potentially select for these more resilient animals. So we're also looking at different breeds. So my PhD work specifically, and a lot of our work started off in purely merino and some meat breeds. But we are looking closely at shedding sheep from different origins with different genetics and hoping to genotype these animals, also look at their physiology and behavior and how they use the land, and seeing, what the most productive sheep is in a changing climate where we're heavily affected by heat events and drought events, and trying to integrate this to sort of, I guess, select climate resilient sheep flock. All right, that's me. I will now pass on to Jamie. And I don't know if you want to do questions right at the end or you want to do questions for my section now. Up to you, Heather.
Why don't we pause them till the end and do it after Jamie's presentation? Because I think that once both pieces of work are put together, there might be some more varied questions for both of you.
Yeah, perfect.
Thanks. Thank you so much.
No worries.
So as Bobbie mentioned, my name is Jamie. I was a postdoc researcher on a trial that was looking specifically at what intervention strategies we could implement on farm right now. So Bobbie's work, as she mentioned, very much focuses on what can we do into the future, building better shade bases, building better genetic lines, and what alterations we need to make in those sorts of things in the long term to help out as the climate changes. But the work that I was a part of was funded by the SA Drought Hub, and they're an initiative from our national government looking at how to mitigate the changing climate, essentially. So the SA Drought Hub is affiliated with the Future Drought Fund, which is national, but their role is on implementation and adoption strategies specifically. So they were looking for projects that could deliver on farm in real time benefits to producers around South Australia as climate's hot already. So we looked at both semi-intensive and extensive on-farm trials to look at increasing the ewe fertility and fecundity, as well as increasing ram libido and fertility. So basically, the aim was to determine whether the impact of supplementation with either melatonin or a vitamin A, D and E drench could improve the fertility of sheep around South Australia during a heat stress period. This ran from November in 2023 through to July 2025, with all sheep supplemented through joining. If you want to click for me, Bobbie, please. So I thought I'd start with just a little bit of background on the South Australian sheep industry more broadly. Like Bobbie mentioned, typically we have a very hot, dry Mediterranean climate with very little summer rain down in the southern parts of Australia. Up north, they do get quite heavy rainfall and that through summer, but that's not something we experience here down in the southern parts. And our summer temperatures usually range from about 28 degrees to 40 degrees. So right now, being the middle of January, we are right in the middle of our summer. So that's from December through to February. And I saw someone ask a chat question very early on what is the time here. In South Australia at the moment, it is 11:07 a.m. on Thursday, just for that context of how the time zones differ. This trial was very, very exciting because it covered all of the regions across South Australia, which I'll go through in a little more detail in a moment. But the majority of producers in South Australia will run a dual purpose merino or a composite. Historically, we're very, very proud of our fine wool merino, but over genetic selection and really selecting for that fine wool, we actually inadvertently selected against reproductive productivity. So in the last 10 to 20 years, there's been that really big pull to try and switch back to increase our reproductive rate. And that is one of the reasons the dual purpose animal, plus with the changing value on wool versus meat. There's just a couple of factors in our Australian industry that have pulled on these little strings over the last few years. Most of our joinings actually occur through late spring through to summer. So for us, that's October through to February. And we're aiming for an autumn lambing when we have more feed available. Natural joinings are our most common, and we use a syndicate mating of around 2%. So most of the producers in this trial followed that. It just was the time that they were joined, which differed based on whereabouts in South Australia they were. So Bobbie, if you want to click again. Before I go into the specifics of where the trials were, I thought it would be worthwhile just going over our treatment rationale. So melatonin is an extremely potent antioxidant, which means it has the potential to mop up free radicals in the body. So when animals or humans or anyone undergo stress, their bodies actually are disrupted in their normal cell functioning, which then produces free radicals in the body. The antioxidants actually act against these free radicals, which then in turn actually offsets the negative impacts of heat stress and allows the body to function more normally. So our idea was that by giving them the antioxidant, we would be basically returning those sheep to their normal status, and therefore wouldn't be impacting their reproduction any further. I'm going to click for me, Bobbie. And then similarly, vitamins A, D, and E all have strong antioxidant properties, but on top of that, they also play key roles at different stages in the reproductive cycle, whether that be for ewes or rams. So vitamin A is essential for embryo development and has a key role in the actual implantation of the embryo in the ewe. Vitamin D is naturally, in ewes that have a naturally increased vitamin D, they're actually more fertile, and they play a role in increasing endometrial thickness. So again, I think that embryo implantation, especially when you're looking to join these animals through heat stress, it's actually really important that you've primed that uterus as well as you possibly can to give that embryo the best chance of survival. And similarly, vitamin E is a very potent antioxidant, so therefore it's going to offset that oxidative stress caused by heat. And there's very, very strong links between vitamin E and increasing in sperm quality in rams, but also embryo quality in ewes. So once again, trying to attack the animals from the inside at all levels to just mitigate the heat stress and do what we can to support a healthy embryo and healthy sperm. Another click. So like I mentioned, the SR Drought Hub was all about innovation and adoption. So we needed something that was already available. So melatonin is already commercially available. It would be for you guys as well as an 18 milligram capsule by a company called Seva, and the trade name for the melatonin is actually Regulin, and it's a single subcutaneous injection. So what you do is you implant, there's a needle at the base of that blue gun, on the end of that blue gun that you can see, and you just inject a little capsule that slowly releases the melatonin in the animal over 100 days. So it costs $6.80, and that's in Australian, so slightly more expensive for you guys. But then it will cover about 100 days in the animal. So for a one-off cost, and once you see the results from the study, it actually does come out quite worthwhile, and you can administer it at joining or up to 30 days prior. And we do have some studies looking at the best time to do it in this application. Similarly, the number of vitamins and minerals and the compositions around the place, I think, still can be optimized. But for the purpose of this trial, we teamed up with a commercial company in Mount Compass of South Australia for an available product called MaxiVit. You can see the levels of each vitamin that were in there. Part of this trial was to look at different methods of delivery as well. Some producers have preferences. So whilst the implant we used for melatonin, we used an oral drench for the AD&E supplement. And it's really cheap. It's only 50 cents Australian per 10 ml dose. And we found that just one dose was super effective in improving reproductive rates. But I would like to have done a dose response looking at 2 or 3 because all of those vitamins are actually quite safe to use. There's a very high limit before they actually become toxic. And similarly, you can administer these ones at joining or up to 3 weeks prior. So once again, you've got that flexibility within your management system to implement it when it's actually convenient for you guys. And this will also last up to 12 weeks in the system. So similar to the melatonin, a once-off dose will actually last your entire joining period. So that will help the implantation as well as that early embryo development, which is absolutely critical to the lifetime of the developing fetus. So specifically in this trial, so over 2022 and 2023, which was a much hotter summer for us here in South Australia, we had 21 producer sites across South Australia. So totaling about 12,500 ewes, with a third of them receiving the Regulin implant, another third receiving the AD&E drench, and the other third remaining in or as a control. All of these animals were run in the same paddock. And often we would duplicate and have 2 paddocks that contained the same, like different groups of the animals, so that we could try and minimize, like Bobbie said, the effect of shade and water resource use and things like that. If they were all in the same paddock, they were offered the same feed, they were under the same conditions. So as best as we could in a commercial trial, we could attribute any changes due to the supplements that we were delivering. We also had about 85 rams on the trial, and there's some very interesting results on these as well, with only half of them received the Regulin, with the other half being controls. In 2023-24, we had fewer producer sites, but we still, and a more mild summer, so it is interesting to compare the results across the 2 years. So within South Australia, we do break down our state into 5, if not six regions. So we have the Eyre Peninsula, which, if Bobbie can circle around that for me with her cursor, over near where you'll see Kynecutter and Woodner up in there. So that is very hot, very dry. And for context, Adelaide, which you can see on the map, from there to there, it's 6.5, 7 hours to drive up. And you go up through Port Augusta and then back down. So it's quite far away from our main township, and a very different climate. And then we move across to the mid-north, which is sort of at the top of that first point. And we had a lot of producer sites in that region. We also have Roseworthy, which is where Bobbie and Will are focused, and we did a lot of our intensive work there. That is where our University of Adelaide campus is. Then we move down to the Murray Mallee, and we have the Barossa Valley in there as well, which is where I'm based at Rosedale for some other intensive trial work. And then we move all the way down to the southeast, which is a much cooler climate compared to your mid-north, just because it's further south. So we did include a huge range of producers across a huge range of regions, just to see how heat stress was impacting each region differently, and how our supplements could help, and if there was a difference based on which regions they were in. So the important bits is the results. So in the 2022-2023 joining, you can see that the percentage of ewes joined with twins was at 123 for a control, and you had 139 lambs for Regulin and 140 for those treated with AD&E, this was pulled across region. I did have other presentations that pull this out by region, because we also presented to individual producer groups within each region to give them their specific results. But overall, so this is pulling across region throughout that whole summer, there was a very big increase in the number of lambs at pregnancy scanning in each of the treatment groups. What's important to note is that it's probably the bigger number of twins compared to singles. So that twinning rate's being increased because of the treatments, as well as the overall pregnancy rate in 2022 and 2023. So for context, our research team would go out to the producer's site at joining. So they would pick a day that was convenient for them. We would head out to their site and we would implant a third of the ewes and drench the other third of the ewes and help them allocate them into their paddocks. We would then come back at pregnancy scanning, and we would record against each ewe whether she was dry, had singles or twins, and relate that data back to get these figures for you. Next slide. In 2023-24, there was still an improvement, but it was no longer significant during this joining period. And I think similar to what Bobbie said, and it is always the way you do a PhD, targeting one thing and the weather or the system will do the complete opposite for you. Our second year was much more mild. So I think that's why we didn't see quite the improvement in pregnancy outcomes. What was interesting though, one producer wanted to look at a Regulin and the AD&E, so drenching the animal as well as giving them Regulin. So within that group, we had control animals, Regulin animals, those treated with the drench, plus those treated with both, all running together. And you can see there's a very, very large increase in the number of lambs in that treatment group in a year that was otherwise quite mild. So that's something we'd really like to work towards in the future, pulling out those differences, as well as looking at different levels of AD&E or other vitamins that we could pull in as well to see if there was an effect. Just for some context, we understand, I'm not sure, I assume you guys are similar over there in Canada, but depending on the age of the animal as well also heavily influences their reproductive potential, mainly being those hoggets in their first mating, usually having a lower lower fertility rate, and as they get older, they seem to come into their own a little bit more. So what you can see here is when we pulled out the hogget ewes against those that were of mixed age, you can see that there is a much bigger increase in the number of fetuses from those joined and those pregnant in hoggets compared to the control. So as a cost management tool, we thought for those producers that can't afford to treat all of their ewes, targeting your hoggets would be a very good place to start to increase your reproductive rate in the first instance. We also looked at, again, not over the Canadian sheep management system, but we have producers scattered throughout South Australia that are starting to mate ewe lambs and looking at mating ewe lambs. And among lots of things, the biggest factor is their mating weight, more so specifically than just their age, but that also needs to be teased out a little bit more. But what you can see from this is that Regulin at joining in ewe lambs not only increases the number pregnant, but increases the number of multiples quite substantially. And again, you need to consider your management and the size of your animals, whether twins is what you're trying to target in your ewe lamb, or if a single healthy lamb from a ewe lamb is the best way forward. But again, that's more data that we want to pull out if we had more funding in future trial work. But again, it's just giving producers those options that if they're trying something in a poor season, they've got a tool that they can use to implement to improve their reproductive potential. Within this work, we focused a little more heavily on Regulin compared to the AD&E, and that was because we had additional funding from Livestock SA. So that is a funding body for research, among other things, here in South Australia. And they put out a project funding call every year for small pockets of money to do a range of research, as long as it's related to improving sheep productivity in some aspect. And they were very interested in looking at the RAM and melatonin and how that interacts. So we conducted one very intensive RAM trial at the Roseworthy campus, similar to what Bobbie said with her work. They had temperature loggers in them. We collected semen from them regularly. We made sure we covered that 40 days prior, and collected all through that process, and then into the next sperm cycle as well to look at the differences. And what we found was that melatonin can reduce your scrotal temperatures by 0.7 of a degree, which you wouldn't think initially is a huge benefit, but when you're talking sperm cells, it actually is, and that was demonstrated through the increase in concentration. But we also had a 4.5% increase in live sperm, and a 5-6% increase in total motility, which is very, very interesting and very, very cool. So those minute changes from the melatonin, and whether that's acting just to reduce the scrotal temperature or whether it's actually also acting on the spermatogenesis and the process in there, we haven't teased that out just yet, but you can see the benefit from implanting a RAM. And then here at the Turretfield Research Centre, they conducted a single sign mating. So they would have one ram joined to 20 ewes. Half of the ewes were treated with melatonin, the other half weren't. And half of the rams received 3 melatonin implants. So rams, you give 3 implants. So that makes it 22 Australian dollars, I guess, to treat your ram, against 7. But the results showed that there was an increase in the number of fetuses from ewes joined by 61% just from treating your rams. So again, just another management tool and just another option for producers. One, I think it's very important, and rams are often overlooked in the scheme of reproduction and looking at your joining, but I think it's very important to pull your rams in 30 days before joining, have a look at their condition, up their feed, and something like a melatonin implant to get these sorts of improvements. Saves you treating 1,000, 2,000 ewes. So on a labour side, it's much more effective. On a cost side, it's much more effective. And I think it's a good way to remind everyone that the rams are just as important if you're pulling them in for this specific thing. Same as simple management things like checking to see if your rams are actually working. You put them out in a syndicate. How do you know which ones are actually the most efficient? Which ones can we pick which ones are more efficient in the heat? is the genetic variation there that you should be pulling out a couple of rams and replacing them with new ones because they aren't coping in the heat, and that's actually affecting your reproductive rate above anything else. And a lot of the feedback we were getting from the producer groups was that they really wanted a dollar figure on what this was going to cost to implement and what this was going to mean in terms of additional income. So I based this off of the 2023-2024 data just because it was the more conservative year. I don't want to be promoting something that's going to be hugely beneficial when we know year on year it's going to be extremely different. So erring on the side of caution, what we found was a 0.3 to a 7% increase in lambs from ewes joined from the AD&E drench, and that's a cost of $50 per 100 ewes. So as an additional income based on the additional number of lambs you would see, that's 56 to 1,300, and this is all in Australian dollars. It was originally curated for our Australian audience here. The Regulin implant, we saw a 0.5 to 20% increase in lambs from ewes joined, which is and at a cost of $680 per 100 ewes. The additional income you can generate from that is 94 to 3,780 Australian dollars again. So once again, you have to really consider the costs. There's a lot more risk in the Regulin implant in terms of an upfront cost, but there's also a lot more reward potentially from doing so. And which is why I also broke it down. That's the cost of treating the ewes. If you look at the cost of a Regulin implant for the ram, you're looking at a 9% increase in lambs from ewes joined if we're looking at our commercial results, not the single site mate at the Turretfield Research Centre. And you're looking at, do need to adjust that, but you're looking at about $1,700 in additional outcome. And you're looking at a cost of, 2 to 3 implants. We'd recommend 3, so that's $22 per ram, which worked out to a cost of $13.60 per 100 ewes if you were working on that 2% syndicate joining rate. And then finally, we only based this off of the 2 trial sites, but it was the cost of the Regulin implant with the AD&E drench and the extra 50 cents on the $6.80 that you were doing to see a 6 to 22% increase in lambs from ewes joined. The additional income starting at $1,300 up to $4,000. It seems very, very beneficial and very much worthwhile. But again, that's only based off of 2 trial sites in the same season, but it was the mild season. So all of these things need to be teased out a little bit more. But for now, you can very much see there is a very clear benefit. I've just seen that half that message point in. The AD&E drench was also administered once. So it was a single dose at the same time we gave the melatonin implant. So the sheep would receive either a single dose of melatonin, the ewes would receive either a single dose of melatonin or the drench of AD&E or no treatment at all. We then divided all of those animals in half and split them into 2 different paddocks. So we could compare paddock differences as well. But we had a number of Regulin, AD&E and control ewes in each paddock. And they all came in at the same time at pregnancy scanning. They'd all been under the same conditions from joining through to preg scanning. So the only difference that we could control was that implant or the drench of AD&E at the time of joining. And then this was something that the Drought Hub wanted us to pull out, was an economic impact of heat. So this graph here is a financial loss due to reduction in lambing rates. And this is based on when ewes are exposed to days over 32 during the week of joining. And that days over 32 degrees for us here in South Australia is extremely important. As Australians, we think heat stress, we've found heat stress to be like a 40-degree day or a 42-degree day for us trying to work and trying to be out there. But for the animals, the research is telling that days as mild in summer as 32 degrees is actually having a hugely negative impact on the reproduction of the animal. And I'm not sure what temperature ranges you guys get over there all the time, but what you would deem a heat stress event is probably more significant than what the animals would deem a heat stress event in terms of their actual body functions. So this chart here assumed a lamb price of 130 Australian per head and a $21 cost of production per head with a baseline lambing rate of 140%. And this was calculated for an average summer and the hottest summer since 1957. We've also then broke it down by region because, as I mentioned, the southeast of South Australia is more mild than what it is up in Kynecutter on the Eyre Peninsula, and that's evident here. So where an average year you could lose $1,200 in Keith, which is in our southeast, in a hot year you're doubling that. And you're seeing similar differences over on the Eyre Peninsula. So I think it's all relative to the environment that the animal is in, and it shouldn't be overlooked if you're deemed to be in a slightly cooler region in your country or in your area. I don't think you should be overlooking the impact of heat stress and what's that actually doing to your financial bottom line. So overall from this work, like I said, the Sheep Industry Fund from Livestock SA, they funded more work specifically under Regulin, which is why there's a little bit more detail in that area. But if we look, the first couple of points here is cumulatively over the entire 2-year trial, we found from our treatment an average increase in pregnancy rates of 2.34%, and the number of twin bearing used increased by 12.73 and 4.66 across the 2 years for an average of a bit over 8.5% increase in the number of twin bearer ewes. So once again, I mentioned it very early on, not necessarily the number of ewes getting pregnant, but the number of ewes carrying twins might be the difference here. And the fetal number scanned per ewe basically is reiterated with an average of 11.8% across the 2 years. With a ewe lamb joining, melatonin resulted in an extra 30 fetuses per 100 ewes. And we're doing more work in this space as well because ewe lambs are very difficult to manage, and their welfare and things like that need to be considered as well. And the biggest finding, and I think the one that's probably the easiest to implement as a producer in terms of Regulin, is that under commercial conditions, if you treat rams, you have the potential to increase lamb numbers by 22% from ewes joined and 11% from ewes pregnant. All right, and once again, as Bobbie mentioned, this project has been funded for a very long time and has had a lot of industry bodies and researchers across the South Australian Research and Development Institute, as well as the Adelaide University, with funding from Meat Livestock Australia, which is a national funding body for us, through to our very own little sheep industry fund and federal projects and bodies funded at a state level as well. And that's it. So I guess I did see a couple of questions in there, Heather. I don't know if you want to shout them out so everyone can hear them.
No, it's great. Thank you so much. This is just fascinating work that you've been doing. So we have a few questions in our chat. So we've got one from Anita O'Brien, who is our on-farm programs lead with Ontario Sheep. She asks, we can have very high humidity coupled with hot temperatures during summer breeding. Can you comment on its compounding effect?
Not specifically. Bobbie can probably answer more to this. Here in Southern Australia, we don't experience the humidity like you guys would and like our far north Queenslanders up in the far north of Australia would. So all of our research is based on that hot, dry climate rather than a humid one. I know for a fact if I go out for a run and it's humid, it hurts me a hell of a lot more than if it's just mild. But Bobbie's research, I think, and her background information in the thermoregulation thing, she's probably a better place to answer a bit more.
Yeah, thanks, Jamie. Yeah, well, we obviously considered that looking at our research, and we did incorporate humidity. So I guess the most common measure to combine those two is the temperature humidity index, which I think there's still a lot of variations of, and it's not specifically crafted to sheep necessarily, but it certainly is a good guide, being able to compound the two and combine the two to get sort of like a context of heat stress or level of heat intensity. So at temperatures of around 32, I guess the temperature humidity index would be around over 70, which is just a unit, and that's considered relatively moderate to extreme heat stress. So certainly in those northern climates and in more humid climates, I would probably lean towards using THI as an index for heat stress. But like we said, in our environment specifically, that's why we've sort of used ambient temperature more commonly, but certainly would be using that in northern climates, and it would be interesting to see if you get similar translations across THI and ambient conditions in terms of productivity in these different cohorts.
Thank you. And then another question from Anita is, would rams benefit from earlier Regulin or vitamin treatment, say 6 to 8 weeks prior to breeding? She said pregnant breeding. I think she meant prior to breeding.
Yes, I would say so. Given they both last for 12 weeks as well, and that's sort of like they peter up to a peak and then they plateau there for a while before it comes back down. I think that 30 to 40 days before joining, so you're affecting that sperm cycle that's actually going to be the semen used in the ewes, and then also helping to get their libido, their heat stress capabilities through that joining period. I think because both products can be sustained in the animal for a long period of time, as long as you're targeting that sperm cycle before and not going too far out that you're not potentially leaving the animals without any in their system if they happen to get a 40-degree day at the end of joining and they need that free radical mop up. I think absolutely.
Thank you. That's fascinating. My question is directed to Dr. Lewis. Baida, you mentioned that some of the heat impact on pregnant ewes results in decreased birth weights. Is this impact specifically limited to any one part of the pregnancy, or is it an issue through the entire pregnancy?
Yeah. So as one of the figures I showed, it can affect lamb birth weight and survivability at any time through gestation. So there's been, I guess, varied research in this space. What they've sometimes found is that heat during early gestation, the ewe and placenta can actually recover quite well and compensate for some early growth restrictions. But it really depends on the intensity and duration of that heat exposure. And I guess that'll sort of portray the extent to what damage or growth restriction has occurred at that time point and whether that they can sort of recover from that or not. But generally speaking, it shows that at any time through gestation, it can have an impact. Like I said, it's not necessarily additive, but there's a lot of, I guess, different results as to what time point has the most impact on the unborn fetus. And so essentially the main way it impacts their birth weight is intrauterine growth restriction. So you're just getting smaller fetal sizes. And some of the results from my work showed at birth some of the morphology, so crown to rump length and forelimb length and things like that sort of showed indications that the lamb had been affected in utero. And I guess it depends on your breeding season and when they're likely to most receive heat. So we sort of join in summer. So we get most of that heat is having impacts early gestation. So in the case of our research and the differences in lamb birth weight that we found suggest that it is having an effect at early gestation as well that they don't necessarily recover from. But certainly more controlled studies have done simulated heat exposure during mid and late gestation and have found effects into the lamb as well. So I think the short answer, yes, anytime through gestation, depending on intensity and duration.
Yeah, that's interesting.
And I'm just adding to that, one of the things I didn't get a chance to do, but the data would be there, is in this heat stress trial that we ran, these were sheep mated from October all the way through to February. So essentially we could look back at weaning rates for these mobs of animals and look back an October joined sheep that was lambing 5 months later, they would have experienced the heat period in that late gestation period. It wasn't ever any retrospective data that I got a chance to look at, but it was one of those things on my list that I was very interested to see. One of the very early reviews was that the majority of your pregnancy losses actually occur during your first 17 days post-mating. So I've always been extremely interested to see how that first 20-day period actually then goes on to affect the growth of the animal and what it looks like on the ground, and whether that is is that just a point of yes or no when it's lost, or those that survive past that point, if that's when the critical heat period is, are then restricted. So there are some very intricate things we can look at. And it wouldn't be too hard because everything's worked with EIDs now. if we had
Yeah.
some funding to go back to those producers and find weaning weights and rates based on joining time.
Yeah, please let us know if you ever look at that. That's really interesting because we do breed a lot of our sheep in the hot period and they get heat exposure in early pregnancy, but there's also a lot of people that breed out of season and they would be getting heat through most of their entire pregnancy. So really applicable to us. So a producer question here is curious on when these ewes were actually caught during the mating cycle. Were they first or second cycle, and how long was the breeding period? Curious if the Regulin was able to get more than first cycles.
Oh my goodness, that is something I've wanted to look at so much, and especially with Bobbie's stuff and that thermoregulation is the melatonin. Are they getting pregnant in their first cycle, but they're losing it, and then they're getting pregnant again, and then is that embryo more compromised because it's actually not the first one in there, so they've had to have a second go on what's shedding that first embryo done to have an effect. For these trials, the average was a normal 35-day mating. So to try and cover those two, to get two estrus cycles in and not blow out your joining for like the 4 to 5 week lambing. And we did in some producer sites, I don't have that data on me, but on some producer sites, we did get the pregnancy scanner to fetal age the animals for us. So we could pull out whether they were early, mid, or late conceived. So we do have that data floating around somewhere. Just another thing that we haven't got around to looking at since we've done the trial. But we do have that data from some sites to see whether the Regulin and AD&E were helping catch more in that first cycle and then exposing it, or whether or not they were helping pick up a second cycle mating.
Thank you. Next question's from Maria. She asks, have you found a drench to be more effective than increasing the AD&E levels in the mineral? And sorry if I missed it, was a teaser ram or ram effect used in this study? And that she really appreciates the data, including the values that you've included.
No teasers in any of the natural matings that we had. From memory, there was 29 odd producer sites or something, but from memory, none of them had a teaser go through first. The single sire matings here at Turretfield, I don't think had any teasers with them. I'm not sure if your work, Bobbie, in the AIs had a teaser work or not.
We did.
Usually, it's common practice to put a teaser out for your AIs. Just to get estrus marks and things like that before the AI. But I don't know any of the producers actually used a teaser prior to mating.
And did you explore increasing the AD&E levels in the mineral at all, or just went straight to the drench?
Just went straight to the drench. It was one of those time constraints with the Drought Hub asking us for a readily available product and having the background knowledge on the AD&E, because there's also AD&E available in an injectable form as well. That's quite routinely used here in Australia. So that was another comparison we were hoping to do as well, was the drench versus the injection. But whether or not you can incorporate it into minerals or feed bases or something like that.
Thank you. What do you think is causing the increased response in ewe lambs for the melatonin?
Oh, good question. Could partly be bringing them in, because the original on-label use for Regulin is to bring sheep that are out of season into season. So that's the original label use for Regulin. For us, using them for joining in the middle of summer is technically an off-label use for the product. So it could potentially have something to do with bringing them onto season and affecting the actual first ovulation of the animal as well. I don't know if Will is or isn't on here, but this was one of his favourite little topics. Was looking at melatonin and its impacts on the ewe lamb and how exactly the mechanism is working. We didn't do that many trial sites, so we haven't been able to pull out that level of in-depth data, but I think it's a combination of bringing those animals on early and also improving the body environment for antioxidant potential and capacity as well.
Thank you. Question from Carmen. How does wool cover affect heat stress?
Yeah, that's a really interesting one. I guess for the purpose of my trial, we really tried to keep it consistent. So all ewes were shorn at the same time. But certainly wool acts as an insulator, and that's in both summer and winter. So they find there is sort of an optimum length in terms of protecting from the heat. So initially when they're shorn, they can offload heat quicker, but they're obviously more affected by solar radiation. Whereas if they have a good length of wool, this sort of helps keep them cooler at the level of the skin. So it definitely affects their ability to cope with heat, and it would definitely affect what's going on physiologically at the animal level. Not something we've looked into specifically. But as we move into looking at shedding sheep and comparing them with merinos, that'd be a really interesting thing to measure. Even there's a variation in the ability of a shedding animal to shed its wool, and some hold a nice saddle of wool, and generally that's linked to higher productivity as compared to the clean shed animal. So is it offering that extra environmental protection that that a merino or a meat breed would hold? So definitely wool is an important factor and something that we'll consider, as we move this research forward and looking at different breeds. But yeah, certainly offers some protection. But initially, having a clean shed or shorn animal, they can emit heat a bit quicker, but ultimately it protects them.
Thank you. Question for Maria. Does ram structure help with heat stress, i.e. a longer scrotum or larger scrotum size?
Yeah, good question. So I did do a range of scrotal measures between my low responding and high responding ram cohorts. And there wasn't any differences between the temperature cohorts, but again, that was relatively small animals. And again, this is something we're really interested in looking at in different breeds, because obviously they are quite anatomically different between breeds and where the scrotum is, and the length of that and how close it is to the body or that ability to regulate. And so we certainly have been looking into that, and also how that affects, their scrotal temperature. We also used an infrared camera on the scrotum in some of our semen collection trials here on site at Roseworthy, as well as at Turretfield. So we're also trying to implement, the thermal camera and looking at how the scrotum varies in terms of its anatomical differences, but also its temperature. So yeah, definitely interesting. I didn't find any differences particularly, but certainly something we'll keep looking at as we expand these trials. It's important to measure. We also scanned the testicle itself, so looking at testicular width and size and density as well as scrotal circumference. So we did measure those aspects as well.
There's also a muscle that is which most producers would have seen as well, the ability of the scrotum to actually come up into the body or drop and hang down really, really low. I moved across to Sardi before we got through that data, but on hot days we were putting all of the rams out undercover in a shed with water, obviously, but having them all in a space that we could actually measure how low or how high, depending which way you want to read it, how much that the testicles were dropping or staying high up in the animal for their ability to cool the testicles themselves, and whether there was any differences in their ability to actually control their scrotal drop and how that was relating to their semen quality when we'd then follow up on the next week that we were semen collecting. It's just another tool that they have within themselves to regulate their own testicular environment.
And is that data that you expect to publish, Dr. Daly?
I would need to come back to Bobbie and Will and those guys at the research team and pull out those bits and pieces. There's so much data from that semen collection trial. Temperature differences, and there's a lot of information in there that's really cool. I guess the goal is always to publish everything.
Yeah, we are in the process of preparing different aspects for publication. There's a huge body of work there. Obviously, a lot of it's very multidimensional, and there's a lot of questions to be answered. So we're working towards publishing a lot of this work, and we can make that all available to you guys. I think we did find larger scrotal size was linked to higher semen volume, which, is not super surprising. But yeah, I guess it'd be interesting to look at variation in that cremaster muscle, and how different sheep are able to regulate the scrotum better. Yeah. Oh, you're on mute, Heather.
Sorry. Question
That's
from
okay.
Brad. How do we select for more resilient, i.e. low response animals?
Yeah. So I guess this is still in the research phase, but obviously we're trying to implement that now with our long-term trial, is deploying these temperature sensors. And as technology is always advancing, ideally it's got to be easier and more practical to monitor their core temperature of animals in the field at a commercial level. And, implementing this into their selection strategies. Ultimately, I think it would be amazing to create a breeding value for heat tolerance. So just as we have breeding values for a whole bunch of traits, whether reproductive, conformation, or otherwise, I think it would be really great to work towards a breeding value for heat tolerance. But to do that, we need to have intense, genetic data, as well as phenotypic data, and, whether there's any correlations to other traits, because we don't want to compromise on other traits, but all the research is suggesting that improved heat resilience is linked to improved reproductive output. So hopefully they're correlated in a positive way, and we can establish a breeding value one day for heat tolerance. But at the moment, classifying these animals based on temperature phenotypes isn't an easy feat. Like I said, it was difficult in a research setting, so really making that a commercial application is difficult. But hopefully as technology advances, like I said, and this research progresses, we can come up with, I guess, producer-ready solutions. But if there is, more resilient breeds and genes or pairs of genes that we find that are linked to heat resilience, maybe we can use that as a proxy for selecting these more resilient individuals. But I guess also indirectly, animals that are performing under hot conditions, they are getting pregnant, they are producing twin lambs, and we're selecting for them anyway. Are we, indirectly selecting for heat resilience already? Is a question I get a lot. And the answer is potentially, but, just having that added, I guess, certainty that you are selecting more resilient animals, and not, I guess, accidentally getting rid of animals that might be actually quite resilient under a changing climate.
On that, there is already a breeding value in dairy cattle for heat tolerance. So I can imagine it's probably not that far down the line that we will find one for sheep just by starting with the ones that they've identified in the dairy cow and move it through that way. So I don't think it's like that far into the future thing. The other thing I think that would be important to consider is where you're getting your rams from. I don't know whether you guys generally do ram sales and things like that, or whether you breed your own rams, but it's quite common in Southern Australia to have a few key breeders. But one of the questions that I've always had is if you're breeding a ram from the southeast where our climate's cooler and you're then moving him up mid-north, how is that actually affecting his tolerance and what you're bringing into your flock? So whether or not you should be considering either retaining more of your own rams and looking at how they perform in one season or something like that, as opposed to buying in rams that might have all of the other traits you're looking for, but they've actually missed the component of climate for your own particular region. But I'm not sure what you guys do in terms of breeding your rams in your mating stock each year, whether that's something that you guys would need to consider.
Yeah, thank you. That's really applicable. Actually, we do a lot of exchange of animals across the country. And as you know, Canada is really large. And we also have some key ram breeders that are located where most of our producers are in Southern Ontario. And we also have producers that bring in semen from New Zealand and Australia. So that's, if you incorporate a heat resistant value, maybe we can get it over here in that way.
Yeah, and if you get eating rams from the upper mid-north of South Australia, they probably are slightly more heat tolerant already, just like Bobbie said, from naturally selecting them over years and years and years. They keep having the higher performance. So, you're
We
getting
should
it
do
from
some
them.
trials. We should send some semen over and we should
We'll
see
take all
We'll
your
come over
semen.
as well. And we'll come visit. We'll help.
So the next question comes from Colleen. She says, so the use of melatonin in rams does not appear to impact libido. Melatonin in humans aids in promoting sleep. Why not the same effect in sheep?
Oh, that's very interesting. That's very cool. I'm not actually sure on the mechanism, but I do know that the more implants you give a ram, the more their libido is increased. So I'm not sure. I don't know if Bobbie knows more on it. I haven't deep dove into that side of the melatonin. It's actually interesting. We're giving some melatonin to boars for another trial I'm doing here at Saudi, and one of the things they're hoping is an increase in libido, so they don't have to try and stimulate the boars themselves to ejaculate. So that's something I'm looking at on the side. I'm not sure of the actual difference as to why it increases, unless it is just they're not as hot.
Yeah.
In summer.
I mean, it's obviously a naturally occurring hormone produced in the pineal gland. And yeah, generally regulates sleep and that sort of thing and is affected by daylight and all those aspects. So, but yeah, whether it's, it's just different use and different mechanism. But I'm also not quite sure how to answer that question, but definitely interesting point to make. And Will might be better off answering that. I don't know. Yeah, like Jamie said, not sure if he's on here, but anyway.
Another question from Colleen. She says, do you anticipate any pushback from consumers with the use of the implants, despite the implant being a natural hormone?
No, it's already commercially used here, not as frequently as what we would like, but it's been very routinely used here for quite some time for bringing your animals into season. So it's not something that's not been in the industry for a while.
The consumer, Jamie, do you think like consumers would be?
Oh, and the consumer. It's tricky. I guess it depends on how you sell it, I suppose.
Wanting to improve them and help them cope with the heat, and that's your your line to I don't know. I mean, they're given a lot of routine husbandry practices and things that are a lot more invasive than that implant. So I guess it's a bit of a cost benefit in a welfare sense on whether they'd be feel a certain way about that application.
But given, like you said, so many people have melatonin for their sleep, I would hope that the general consumer would see it as a positive application for the animals. And I think it's all just perception and how well we can market. It's probably similar for you guys. You get some that are super supportive of the move to improve things, and others that aren't. I think melatonin would be one of the more conservative, and would probably have less pushback than some of the other things that people have tried in the past, I'd say. But we've got the background and the knowledge to know that it's a good thing, so it's tricky to answer that one.
Right. Well, thank you so much. Anita, I think, wanted to say something.
Well, and it's with regards to the melatonin. So in your trials, you used an implant. Colleen brought forward that as humans, we use it as an oral, like we orally consume it. Can you just comment on if someone thought, oh, we can use the human version, give it to our sheep? What's the effect of it in given orally in terms of what being digested, and then how much is left? Do we know that?
We've actually done. Sorry, Jamie. We've actually done a bit of work with an oral melatonin drench, so you can get pure melatonin powder. Using the human one, I think would be not very cost effective. I imagine be expensive when you're implementing it to a cohort of sheep. But we do have some melatonin powder, and we had different doses put in some clear vegetable capsules, and we gave that, and we administered that orally with water. And that was an intensive honours trial here done in an animal house. And there's actually some really positive results in that. And that I hope to publish along with the honours student, Sarah. And we found some really positive results in reducing core temperature with the oral drench of melatonin. I guess with ruminants, you always need to consider how it's going to be broken down in the rumen. But yes, we found some really positive results, and that's something that'd be easily administered. But whether it has less of a long-lasting impact on the animal, it might be something that you would do just prior to joining in the ewes, perhaps. Just give them an oral melatonin drench, help reduce that core temperature. It's something we sort of need to look at further, but the intensive work is certainly promising with the oral drench. Yeah.
And
Thank
like
you
Bobbie
so
said,
much.
it doesn't stay stable for that long either. Like one of the issues with trying to mill it into a feed, which was the other way we thought would be really, really effective. You have to mill the feed and then lay the powder over it and spray it with ethanol to get it to coat the thing. So it's really, really tricky to actually integrate into a feed ration or something like that. So like Bobbie mentioned, it wouldn't probably stay stable in the system very long as a drenched option, which would make it a little bit tricky. And the implant's just really simple. And there's been that much research done on its sustained release over that 100 days that it's at the moment the best way forward we can see.
Well, thank you so much for speaking to that. That all sounds really promising. Does anybody else have any final questions before we say goodbye to our researchers tonight? So I think we're okay. Oh, we got one more popped up here. Sorry, from Ursina. She says, is the ADE dose adjusted by weight, or is it the same for all the ewes?
It was the same for all of the ewes in this case. I know the Tapari handling system, which some of our producers had, it actually will weigh the animal for you and then let you base, and then it'll feed the drench on the dose that you need based on weight. But for the purpose of this trial, we have the weight and the body condition, and it wasn't different between treatments. And there was small variation within each treatment, but nothing outside of the ordinary. And we excluded the really, really heavy animals or the really light, sickly looking animals in most cases. But no, just a single 10 mil drench down the race, same one for every animal.
Wonderful. Thank you so much, both of you, for coming out and sharing all this with us. We really appreciate it tremendously. I'd like to thank all of our producers for joining us tonight, and I will send you all out the link when it goes up on our YouTube site so that you can refer back to it, because I'm sure we're all going to want to check up on those slides just to see how what the things were after the presentation. Thank you so much, everybody, and have a good night.
Thank you so much, Heather, for having us also, and it was a really great discussion. So very happy to be involved, and thanks again.
Yeah, absolute fantastic opportunity for you guys to reach out to us and see that our research is reaching you guys over there. That's very, very cool. And thank you so much.
We can do something again sometime, and we got even more cool results to share with you.